Hi, Mr. Lee here. All right, we're going to solve some log equations. So this is numbers 32 to 35. We can write answers in exact form, so we'll kind of just see what we get here. All right, number 32. All right, so you have a 1/2 here. The pattern is to try to find similar bases, right? So if you have 32, that's the same thing as 2 to the power of 5. And then 1/2, the reciprocal of 1/2 is actually 2. All right, so there's different ways to do this problem. I'm going to change this 1/2 to a 2, which is the reciprocal of 1/2, right? This is the same thing as 2 over 1. If you do the reciprocal, then your exponent just switches signs. So this becomes negative 4x. Okay, so 1/2 to the 4x is actually the same thing as 2 over 1 to the negative 4x. Okay, and the reason I do that is because now we have this base of 2, which we can now match with this right side. This is going to be 2 to the power of 5. We even put that in parentheses. So basically when that happens, we're able to convert it to the same base. Now we just set the exponents equal to each other. Negative 4x equals 5, x equals a negative 5/4, right? Which is the same thing as negative 1.25. Okay, so it's slightly tricky, but the 2 should be an indicator, or at least a clue. Let me try to change it to a base of 2. Let me try to change this to a base of 2, and then get your final answer. 33. Okay, so I want to separate everything from the exponential term. So right now, it's being multiplied by 7, and then you're doing 2 plus that. So I'm going to subtract 2 on both sides. We get 7 times 3 to the x equals 42. I'm going to divide both sides by 7. And there's no way to change these to the same base, so we're going to use our logarithms here. Right? This is an exponential form. I'm going to change it into log form. So same base, log base 3. You can do your around the world method. You should get log base 3 of 6 equals x. Okay, you can always double check as you go. If I wrote this correctly, start the base of my log. 3 to the power of x equals 6. That's what I originally had here. So x is by itself now. Here's my answer. Log base 3 of 6. All right, so again, this is exponential form, the log form. 3 to the power of x equals 6. That was the original. So we know we rewrote it correctly. And there's your x value. That was 33. On to number 34. Okay, this one's not too bad. We have log base 3 of something equals log base 3 of something. So you have logs of the same bases. That means, logically, whatever's inside, they're just equal to each other, right? So I can solve this simple equation. Let's subtract 2x on both sides. And then subtract 10 on both sides. You get x equals negative 2. This one we should check for an extraneous solution. So if I plug negative 2 back in, both of these are going to become 0, I think, right? So we go 5 times negative 2 plus 10. So if inside your log is a 0, that's actually an undefined number, right? Because if you take 3 to some power, it's never going to equal 0. 3 to some power will always be above 0. If you think about like your exponential equations, the asymptote is at 0. Okay, you can test it on the graphing calculator as well, but you cannot have inside of this log function be 0 or negative. Okay, so that's why there's no solution on this one, or do you say negative 2 is extraneous, right? So that's number 34. Okay, 35. All right, so we have two logs being added, the same base. We should be able to combine them into a single log. So the rule is you're adding logs to the same base. I'm going to multiply the insides. So x times x minus 12, that all still equals 2. Okay, we have a single log now, so we can convert from log form to exponential. So follow your around the world order. 8 to the power of 2 should be equal to x times x minus 12. And then we just simplify a bit. 64 equals x squared minus 12x. I'm going to subtract 64 on both sides. Get a chance to factor this guy, which we should be able to. All right. What is our winning combo? I think 16 and 4, right? Minus 16 and plus 4. Let's double check everything. X squared minus 16x plus 4x is negative 12x. And then 4 times negative 16 is negative 64. So that's good. So that means x equals negative 4 or x equals 16. Okay, negative 4 should be an extraneous solution because if you plug it back in, you get a negative 4 here, right? Log base 8 of negative number. 8 to some power will never equal a negative, so it's invalid. 16 will be fine, right? You have a positive number here as a 16, and then 16 minus 12 is still positive. So negative 4 is extraneous. Your final answer is x equals 16 only. Should be good.